Hi girls, so I thought I'd do a couple of revision videos. Firstly, we'll do polynomial division, and I want to remind you of the analog to numerical long division. So 507 divided by 16, so how many times does 16 go into 5? It doesn't. How many times does 16 go into 50? 3 times, I think. 3 times 16 is 48. Is that right? I think so. Which leaves me 2, and then I pull down the 7. And then I start again. I say, how many times does 16 go into 27? Just the 1. Multiply through 16. Subtract. Oops, sorry. And I get, what's that, 11? So that gives me 16 goes into 507, 31 times, remainder 11. Now what this means is it means that 507 equals 16 lots of 31 plus 11. So that's what it means to divide in by a number. So this thing here we'll call the divisor. Sorry. Getting used to this again. This will be the remainder, and then we'll call the 31 the quotient or something. It doesn't really matter what we call them. And the important thing to remember is that we define the remainder to be something that is less than 16, right? If it's not less than 16, you don't call it a remainder. It means you haven't divided it in enough times. So I'll just make up a polynomial division. So let's divide a cubic by a linear thing. So let's say, how many times does x minus 1 go into x cubed minus 7x squared plus 4x minus 1. So, it's similar. We're only really concerned, oops, that's not a highlighter. We're only really concerned with the x. So all we're really concerned about is how many times does x go into whatever the biggest thing is. And it's kind of similar to the way you divide 16, and you kind of just say what's the biggest chunk you can take out. So x goes into x cubed, x squared times. So we get an x squared up there. Oops. And then I multiply through. So I multiply through the divisor by x squared. So that gives me x cubed minus x squared. Subtract, so they go away. Minus minus is plus, so I get minus 6x squared, and then I drag everything down. So plus 4x plus minus 1. You don't have to drag the minus 1 down yet if you don't want to. So then I start again. How many times does x go into minus 6x squared? So that's minus 6x times. Multiply through. Subtract. So that becomes minus 2x minus 1. How many times does that go in? Minus 2 times. Multiply through. So minus minus becomes plus. Subtract. So that gives me remainder minus 3. So what does that mean? So that means, I'm just going to rub out the left hand side now. So that means if I want to express my polynomial in a slightly different way, I can say that the polynomial, which I call p, which is x cubed minus 7x squared plus 4x minus 1, is equal to the divisor, x minus 1, times the quotient, plus the remainder, which is minus 3. And the important thing is that, again, as in the other case, this is smaller than this. Now here, we say that smaller means the degree. Right, the coefficient in front of the number, i.e. whether it's minus 3 or minus 2 million, doesn't matter. All that matters is that the degree is smaller than the linear thing. So anytime I divide by a line, my remainder should be a number. Anytime if I were to divide by something like this, a quadratic, my remainder would be something like this. linear. It doesn't have to, like, it could be a linear with a 0 coefficient in front of x, but it still has to be a linear function. So I'll just move on to a new slide, and I just want to remind you, I'm not actually going to do it, but I want to remind you that, let's just say, for example, I was dividing, I don't know, 2x minus 7 into x cubed minus 3. I just want to remind you that it's always a good idea to put in the plus 0x squared, and plus 0x in your working, so that you don't make a mistake forgetting these are here. And it also helps to remind you if you need to do minus minus to turn it into a plus. Okay, so next I want to remind you about the remainder theorem. So what we were just doing just then, we had some polynomial p dividing it by something called d, and then we get something called qx, which is a quotient, and plus my remainder. So if I go back, in this example, my remainder was minus 3, my divisor was x minus 1, and this thing here was my polynomial. So the remainder theorem says that when I divide by something of the form x minus alpha, so if that's, sorry, I'll write that again. So let's say I divide by x minus alpha, then the remainder is always equal to p evaluated at alpha. And it extends to saying that if I divide by any linear thing, then the remainder is the polynomial when you sub in what would be the root to that polynomial. So in other words, if I was drawing it, so what I'm trying to say is that if I, for example, if I divide by this, then the remainder would be p evaluated at 3 over 2. Right, because 3 over 2 is where this curve, if I'm doing this, would pass through the x-axis, or something like that, depending on the application, obviously. And the proof is pretty easy, but it's hard to make sense of in a way. So you get p alpha. All I'm doing, first of all, is everywhere I wrote x up there, up the top here. Oops, sorry. I'm now writing alpha. And I'm over the photo of Abby, but that's okay. Hopefully you can read it. And the whole point is that this, if I sub in alpha minus alpha, guess what? It equals 0. So all that now goes away. And I'm left with p evaluated at alpha equals the remainder. And that's it. Okay? And because r alpha is a number, because I know if I'm dividing by a linear thing, it's a number, it is exactly r alpha. That is the number. R is always the same. R is actually not a function of x. Right? It doesn't matter what value of x you put in, you always get the same thing out for r. And that's the remainder theorem, which is pretty useful. Not quite as useful as the factor theorem, but it does come up quite a lot in exam situations and the like. Okay, so I want to show you one more very quick thing. So, oops, sorry, that was not meant to be there. And I don't know what my... Okay. So let's say I wanted to divide x cubed minus x squared minus x plus 10 by x plus 2. Now, I've done this already. Well, I haven't actually, but I know the answer is this, because I just did it by expansion rather than dividing. So I know that that is the answer. But what I want to remind you of is this, which is to say, let's say I know that this polynomial here, and this is useful for the next video, this polynomial here can be divided by this and leave no remainder. Okay, if I know that, then I can do this technique, which is to say, I take the divisor, which was that cubic, minus x squared minus x plus 10, and I set it equal to the thing I divided by times a quadratic. I know it's a quadratic because I have to get a cubic, and I know because it's x cubed, I know that the quadratic is just x squared, and because it is plus 10, I know that this times whatever the number is at the end is the only way to get 10, so it has to be plus 5. And then I don't know what goes in the middle yet, so I just call it AX. Sorry, I'm going to be messy. And now I just expand the right hand side. So I get x cubed plus ax squared plus 2x squared plus, and I stop. I don't care what happens next, because I know that this is the entire x squared term, which means that it must be exactly the same as this, so therefore a must equal minus 3, because minus 3 plus 2 is minus 1. And that's a really useful technique if I know that x plus 2 is a divisor. So for example, I might know the curve has a root at minus 2 or something like that, which is most commonly what you do know, or something like that. And it is generally faster than polynomial division, but it's not always going to be what we need to do, because we're going to need to do other things where the standard polynomial division that we saw at the start is necessary. Alright, I hope you're having a good holiday. My dog is having a good holiday, and so am I. I'll put another video up in probably a couple of days. Okay.